This is the first part for Lesson 2.4, Changes in Graphs. Please note that this lesson is a remake of previous lessons, and so the numbers shown in the video, as far as the number of problem, it may not match what's in your book. There's one little new aspect, well actually two, okay? So we're going to talk about the positive region of a graph and a negative region of a graph. And when we talk about that, when you look at your graph, you've got your x-axis, and that kind of divides. Up here is positive, and down here is negative. So anything above the graph is the positive part, and anything below the graph is the negative part. So we're going to talk about that as we do all of the other things that we've done before. So let's just start with the things that we know. State the x and y intercepts as an ordered pair. So the x-intercept right there is 4, 0. The y-intercept is 0, 7. B, state whether the function is increasing or decreasing. So can you see that real quickly? That one is going to be decreasing. Okay, C, state the domain and range using interval notation. So we've done that before. So the domain, this is a linear equation. So I remember that linear equations are negative infinity to infinity, and the range is also negative infinity to infinity, because it's linear. So I'm just going to write linear just to tell you how we know that. All right, now I'm going to skip E, and I'm going to come back to that. And we also D, so D and E, we're going to come back to those. Okay, the next one we're going to go to is F, the average rate of change for the interval from 0 to 4. So from 0, right here, to 4. So I'm looking from here to here. What's the slope? And remember that because it's linear, it's a constant rate of change, so it doesn't really matter where you look. But if I look here, it's going to go down 7 over 4. So down 7 over 4. That cannot be reduced, so that's it. G, write the equation, the asymptote. Because it's linear, it does not have an asymptote, so none. So we're going to go back now. Let's talk about the new part. So D and E. So D, it says in two different colors, identify the positive and negative function. You are not going to do that for positive and do that for negative. That is not what this is. The function is just the line. So what you're going to do is you're going to get a color and you're going to highlight. I like to use a highlighter for this kind of problem right here. You're going to highlight the positive part, and in a different color, you're going to highlight the negative part. That's going to help when we go to do part E. So the positive part is the part above the x-axis, and the negative part is below. Now, identifying the interval, it says with respect to the domain, and that tells us how we're going to operate this for each the positive and the negative function. So because it's on the domain, we're looking at x as being our sidewalk. Now, as the guy is walking, when he looks at the graph, does he have to look up or down? He has to look up. And he has to keep looking up until he gets right there. When he's standing right there in that spot, that's a neutral. It's not positive or negative. And then when he passes that spot, now he's got to look down. So as the man is walking, or whoever it is, as he's walking on X, when he starts at negative infinity, it's going to be a positive function until he gets where? Until he gets to 4. Now, it's not inclusive because when he's on 4, it's not positive. It's not negative either. Now, for the negative part of the function, the guy is still walking on the x-axis. So we're still, with respect to the domain, so we're still going to say x is an element of. And that's something people get confused. They think that they should go y because when we did domain and range, that's what we did. But this is talking about the interval with respect to the domain. So this is, I'm still on the x-axis walking along. So starting at 4, we're in the negative part of the graph all the way to infinity. So all the way out here, it's negative. And so that's how you're going to do a positive and negative interval. So let's try another one. Okay, so same thing. I want you to pause the video and do as many parts of this as you can without help. And then when you're ready to see the answers, or when you come to a point where you can't do any more yourself, then come on and check and see how to do the rest of it. Okay, the x and y intercepts. X-intercept 1, 0. The y-intercept is 0, negative 2. The function is increasing. C, the domain and range. So the domain, this is an exponential function. I can tell that because of the way it looks. So I'm going to say x is going to go from negative infinity to infinity. Now the range is something different. So I have to look at this and I have to say, okay, well, here's an asymptote right there. and that's at -4, and it's going to go up high to infinity. So my range is going to be y as an element of, because remember range is y, -4 to infinity. It's not inclusive on the 4. You're not going to put a square bracket there because it doesn't touch the 4. It just gets really close. I'm going to skip and I'll come back to part E and D. Let's go to F. So F, it says the interval from -1 to 2. So from -1 to +2, I need to find the average rate of change. So I'm going to come down here. So think about, if you need to think about your little imaginary brain scissors, you're going to go from right there to right there. So within that interval, I'm looking at that rate. So I'm going to go up 1, 2, 3, 4, 5, 6, 7 over 1, 2, 3, up 7 over 3. And then G is write the equation of the asymptote, if any, and that's going to be none. Okay, I'm going to erase what I have on the graph so I can concentrate on the positive and negative parts of this. That seems to be a little bit trickier, and that's one of the reasons why we save this until the last. But part D with 2 different colors identify the positive and the negative. So remember the x-axis is the dividing line. So anything above the x-axis is going to be positive, and anything below the x-axis is going to be negative. Okay, so I've done part D. Part E, write the interval with respect to the domain. And that just tells us both of these are going to be x is an element, x is an element. So as you think about the little guy walking, okay, as he's walking right there, it's below him. So we're talking, this is negative. So the negative part, that starts at -infinity. And as he's walking, he's still in the negative part. Still, until he gets there. So until he gets to 1, negative. Once he gets to 1, it's positive. And it's positive now until infinity. And so those are the intervals with respect to the domain. Remember, domain is x, for positive and negative functions. Okay, now the last one, this is called a quadratic function, and we really won't be seeing many of these, hardly at all, until secondary 2. But this is just a good one to practice a couple of things with. So a quadratic equation, that's something like y equals x squared. So that's actually y equals x squared would be here, and so because it went down 1, 2, 3, 4, it's actually going to be y equals x squared minus 4. So see how that works. Anyway, not that that's important. You don't really have to know what the equation is or anything like that, but just telling you that that's what that is. Now we're going to use this. It's got a couple of different little twists and turns because of it being a quadratic. Let's just talk about those things that we know. So let's do the easy parts first. So the x and y intercepts. So this one, it has 2 x-intercepts. So it's going to have at 2, 0 and at -2, 0. It doesn't matter which one you write first. You can do the 2 or the -2. And then the y-intercept, there's only one of those, and that's going to be here down here at 0, -4. Now for part B, as far as the increasing and decreasing, we have in A for not applicable, because if you start on the left, it's going down, but then it comes back up. So in secondary 2, we talk about that and how we address that issue when we talk about increasing or decreasing, but it's not going to apply to us here. Okay, the domain and range. You can actually do this using the same idea of the guy walking along. Can he see a graph? Yes, 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 yes. He can see a graph forever. This is going out same as an exponential. It goes out, and sideways. And so the domain is going to be all real numbers. Okay, and that's always true for quadratics. The domain is always all real numbers. The range, how low does this go? So let's look. So if I look at how low this goes, okay, it's going as low as right there. Now we said that's a y-intercept, so it's actually touching. There's no asymptote there. Quadratics don't have asymptotes. They actually touch that point, and so the range is going to be y as an element of -4, and that's going to be inclusive to infinity. We'll skip E, we'll come back to that. So the interval from -3 to 0, what's the average rate of change? So from -3 to 0, so I'm going to go up and find the graph right there, and I'm going to go find the graph right there. So this is what I'm looking at. What's the slope? So this is going down 9 and over 3, so down 9 over 3, which reduces to -3. Okay, next one is let's do another one with an interval. This time the interval is going to be from 1 to 2. So from 1 to 2. So I'm looking at the graph right there, 2 right there. So that's going to be up 3 over 1. Okay, so from here, wherever we were, let's see, from -3. So the average rate of change there is -3, and that's going to be the same as this little piece right there. Now notice that if we did from 0 to 2, that's going to be a different rate of change. That's not going to be quite as steep as 3. It's going to be up 4 and over 2, so it's only going to be a slope of 2. So it just depends on the interval that we're looking at, and that's why those are different questions. Now as far as highlighting the positive and negative, the positive, remember, is above the x-axis, so these are positive. And the negative is going to be below the x-axis, so that's the negative part. So in order to tell what the interval is with respect to the domain, get your little guy walking on the sidewalk. Now, as he's walking and he sees the graph, he has to look straight up or straight down. Does he have to look up? Yes. It's above him, above him, above him, above him, until he gets right there. So the positive is going to be from -infinity until he gets to -2. And then it goes negative. So now at this point, it's below, 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 until he gets there. So the negative is not y. X is going to be negative from -2 until he gets to +2. And then what happens? Then we're looking up again. So we have another positive interval. So I'm going to put that in here. I need more room. That's going to be starting at 2 to infinity. So that's the positive one. So on a quadratic, it's kind of fun to ask that question just because there's more positive intervals, there's more x-intercepts. You can see a lot of different average rates of change. So this is just something to explore. You don't need to stress out about being able to do that on your own. You need to do the other ones on your own, but this is just something to explore. This lesson will be continued in the next video.